The purpose of this video is to walk through a model of kind of why people who are fully informed, understand all of the risks, understand all of the costs, still choose to engage in risky behaviors. And the basic idea of the model is going to be, well, the marginal utility is greater than the marginal cost. And that would be why they engage in it, and they'll engage in it until those two marginal return, marginal utility and marginal cost, equalize. So let's begin with just reminding you, a usual assumption with economics is that for any kind of activity, in this case I've gone very specific with calling it some behavior, typically gives us more happiness when we consume a little of it, and then the extra happiness we get declines as we consume more of it. So that if we were to plot utility against the amount of consumption we have or the amount that we do some behavior, we would see positive but then diminishing marginal returns. And if we want to plot that in the marginal utility space rather than utility, but in marginal utility space, we would then have, starts off very high, and as you do more of it, that utility declines. So to figure out how people are going to make decisions in these models of risky behaviors, we need to know something about marginal cost. And usually we'll assume that we face positive marginal cost. So that's the origin, and this goes up. And that those marginal costs, though always positive, are diminishing. So we have this declining marginal cost. Now, that might be confusing. Why would marginal cost be declining for some risky behavior? The intuition there is kind of the same as the utility one, where you had total utility rising as you consume more of it. Here we have total cost rising. Remember, marginal costs are always positive. But the growth in costs as you do more and more of the behavior gets smaller. So to pick an example, if the first time you use intravenous drugs is the first time that you get exposed to all the risks associated with using intravenous drugs. By the time you've used, a ton of intravenous drugs, the odds that you get some new bad thing that you haven't already been exposed to are much lower. Why is that? They're lower because you've already been exposed to the risks a lot, so that you can only get HIV once. You can only get addicted once, and once you you can only enter the state of being addicted once, and after you've become addicted, you're addicted. After you have HIV, you have HIV. So that the more you do something, the more total cost, the likelihood you have HIV, the likelihood that you're addicted increases, but it increases at a diminishing rate because you have that cumulative risk exposure as you march down that marginal cost curve. Now we're ready to put these two things together. We'll draw marginal utility and marginal cost together. So let's first draw marginal utility, positive diminishing marginal utility. Now let's draw marginal cost, positive diminishing marginal cost, and then where these two intersect, so where marginal utility equals marginal cost, and that gives us the optimal amount of some behavior with a given marginal return and marginal cost. So that's equilibrium. As an exercise, what happens when marginal cost is everywhere above marginal utility? What's the equilibrium then? Now we'll use this framework to discuss people's decisions that are directly relevant for HIV. So I'm going to take the same framework and just relabel things. We still have marginal utility and marginal cost, but now that risky behavior will model as the number of sort of sex partners you have. Okay? The assumption on utility, as we had before, is of positive diminishing marginal utility, so that the first sex partner you take gives you very high utility, and then that declines as you have more and more. So we'll say that's our marginal utility from taking on additional sex partners. Now let's think about marginal cost. We'll assume that the marginal cost of taking on an additional sex partner is that you contract, have a risk of contracting HIV. So that's the big cost. The probability then that you've contracted it is increasing in the number of sex partners, but the probability that the next sex partner gives you HIV is diminishing in the number of partners because there's a probability that you've already acquired it from your previous partners. So we might have an equilibrium where we might have a marginal cost curve, where in a country where HIV is very prevalent, that's extremely steep. And so that ends up in a high prevalence country where we choose then to have a relatively large number of partners and therefore a relatively high prevalence of people who probably have HIV. Let's consider a different scenario now where marginal costs are very low, so that each new sex partner that you have doesn't really dramatically increase the chance that you have HIV. Well, you can wind up with an equilibrium, say, like this, where, because the prevalence is relatively low, at higher levels of partners, the probability that you already have HIV is lower, so the risk in terms of acquiring HIV is greater, so you wind up with higher marginal costs in the low prevalence country at a large number of partners. But look at with the equilibrium, where does marginal utility equals marginal cost? Well, it's right here. So before we had number of partners high, now we wind up with number of partners low, so that paradoxically in a lower prevalence country, you have people engaging in less risky behavior than in the high prevalence country. The intuition, of course, is that the reason why people do more risky behavior in the high prevalence country is they know they're going to have a certain number of sex partners, and they know then that they're going to have a high probability of acquiring HIV, so they become kind of fatalistic. So this could be called a model of fatalism. There's a number of kind of fun ways you can play around with this model that lead to some kind of counterintuitive insights. I've applied this in the context of sex partners, but I think you can tell the same story with, use of needles, of intravenous drugs, and other sorts of risky behaviors too. So you can take the same basic model and apply it to different scenarios. But in terms of some of the counterintuitive implications of this fairly intuitive model, one of the things to think about is what's the impact of telling people that the prevalence of HIV in the country is higher than they would have expected. Okay. So the way that we would do this is, let's first start an equilibrium like I've drawn here, where you have a fairly low prevalence of HIV, meaning then the marginal cost of taking on an additional sex partner remains relatively high, and we're fixing marginal utility. And now the question is, how do people react to information that HIV is way more prevalent? Well, in a setting where people don't know their own HIV status, all of a sudden, they'll look at the number of sex partners they've had, and if the probability that they have HIV is much higher than they believed, what does that do? Well, let's say that they learn that the prevalence rate is a lot higher, so the marginal cost curve then ends up looking a lot steeper, and so now you've all of a sudden gone from an equilibrium where people thought HIV was lower and therefore engaged in fewer risky transactions. Now they learn HIV is much higher, and what happens? Well, they're induced to engage in a lot more risky behaviors. So this kind of simple model is one where actually information about the prevalence of a disease or the risks associated with some risky behavior can induce more of that behavior, which I think is fair to say is kind of counterintuitive. You can do some more playing around with this model too. It should be obvious that the results you get are somewhat dependent on the shape of the marginal utility curve, you could imagine looking at how the model changes when you have two types of people. One who has a high marginal utility of additional sex partners, and one who has a relatively low marginal utility of taking on additional sex partners. If you split the world up that way, what are the implications for then the pool of possible sex partners? I think that you can write that out and should be able to show yourself that you wind up with a pool of sex partners that are very likely to have a lot of HIV, and therefore you have this kind of increasing risks of exposure to HIV, and so they're kind of a feedback from having these latent types into the actual shape of the marginal cost curve itself. The other thing you could use this model to think about is what happens if people, if you move from an equilibrium like this one, where people don't know their status, to a different world where people can perpetually retest themselves, and therefore they'll know their status, but people can't credibly convey this information, so they would never know their partner's status. How does the equilibrium in the model change? How would you draw the model differently with that scenario, and how does that then change the equilibrium of the model? Are fun things to think about.